Welcome everyone to this IAQM webinar, PM2.5 Emissions Inventory and Source Apportionment for the City of London. This webinar is going to provide an overview of a study examining the extent to which the City of London Corporation could influence levels of PM2.5 in the square mile. I'm really pleased to introduce our speaker today, Angela Goodhand. Angela is a principal air quality consultant at Ricardo and has over 15 years' experience as an environmental consultant. She specialises in delivering environmental impact assessments with respect to air quality, odour and dust for a wide spectrum of projects such as residential, mixed-use developments, energy from waste, biomass, industrial and large infrastructure schemes. Thank you to Angela for joining. As always, there will be the chance for questions at the end of her presentation, so please do submit these in the Q&A option, which you should find at the bottom of your screen, and you can do that at any point during the presentations, and I will then ask these on your behalf later on. So great to see so many of you here today. Thank you for logging in, and I'll now hand over to Angela. Thank you.
Hello, everyone, and thank you so much for joining this IAQM lunchtime webinar. As Ethne has just said, my name is Angela Goodhand. I'm a principal air quality consultant at Ricardo, and I've been in the air quality industry for around 15 years now. And my main areas of specialty, as she said, has been in preparing air quality assessments for different types of projects as required by the planning and permitting regime. However, since joining Ricardo about 3 years ago, I've been involved in preparing air quality action plans and emissions inventories. So I was recently involved in the air quality action plan and emissions inventory for 7 cities in Asia, which was commissioned by the Asian Development Bank. And I was also involved in this City of London PM2.5 emissions inventory project. The aim of this presentation is to give you an insight on what it entails in developing a robust emissions inventory using this City of London PM2.5 emissions inventory project. So the agenda for the day. First of all, I'll be giving an introduction to the topic. Next, I'll give a background to the project. Next, I'll give an overview on the methodology used to compile the emissions inventory. Next, I'll give all the process of compiling the emissions inventory. Next, I'll be giving an overview of the emissions inventory results, followed by some supporting analysis that was done for the emissions inventory, and also provide the limitations and recommendations for the study, and then give a summary of everything I've spoken about. So first of all, what is PM2.5? PM2.5 are very small particles that are released directly into the atmosphere. They could be released from man-made activities like wood burning. They could also be released from natural activities like sea salt spray. And they could also be formed in the atmosphere by the mixing of gases, which then condense to form particles. These are called secondary PM. So as you can see from the picture to the right, these particles are very small. They are less than 2.5 micrometers in diameter. And you can see the picture shows how small they are compared to a strand of hair and also compared to sand. So why is PM2.5 relevant? It's relevant because the breathing in of PM2.5 can lead to health impacts. The short-term exposure to PM2.5 can lead to difficulty in breathing. It can worsen the existing conditions of asthma, and it can also worsen chronic obstructive pulmonary disease. Long-term exposure to PM2.5 can lead to premature death for people that have got existing heart or lung diseases. So what is an emissions inventory? An emissions inventory is a systematic compilation of all the relevant emissions from different sources in a geographical area and for a particular time period. The sources could range from non-road mobile machinery, which could include things like excavators. Sources could also include heat and power sources like CHPs, boilers, and the sources also include things like transport. So this could be rail, road, flights. Now, why is emissions inventory important? An emissions inventory is important because it can be used to understand the magnitude of emission sources. It's also a very useful tool for stakeholders, policymakers, and anybody involved in air quality management, as they can use this to develop very effective emission reduction strategies. And finally, an emissions inventory is also a very good building block for dispersion models, because then you can use this to predict the pollutant concentrations that humans will be exposed to, and then understand the corresponding health impacts. So what's the background to this project? City of London Corporation governs the square mile, which you can see in the picture to the right. And they are expected to meet the new Environmental Act targets of 10 micrograms per cubic meter, which has been set for the protection of human health. They currently monitor PM2.5 at 2 monitoring locations that is shown in the map at Farringdon Street and Aldgate Streets. And the annual mean PM2.5 at these 2 locations is around 12 micrograms per cubic meter. So they are currently exceeding this 10 micrograms per cubic meter. But the only thing to note is that this target is not meant to be met until 2040. The current air quality standards regulations for PM2.5 is a value of 20 micrograms per cubic meter. And they're currently meeting that target. City of London is aware that the PM2.5 within their area is coming from local sources and also coming from sources outside of City of London. And there are other emissions inventories available, like the National Atmospheric Emissions Inventory, which is prepared by Ricardo, and the London Atmospheric Emissions Inventory. However, these emissions inventories are not detailed enough because they are at a spatial resolution of 1 kilometer by 1 kilometer. So you can identify hotspots with those emissions inventories. So City of London decided to commission this project so that they can understand and get a better idea of all the PM2.5 emissions in the City of London for the year 2019, to understand all the percentage contribution of all the sources, and then they can understand the sources that they'll be able to control. So the process for the methodology for the emissions inventory has followed the standard procedure, where the emissions is multiplied, the emission source activity is multiplied by the emissions factor. And the emission source activity could range from things like the rating of the boiler in kilowatts hour. Also, you could have the number of vehicles. And then when it comes to emission factors, this could be in grams per kilowatt hour, or it could be grams per kilometer driven. The process for this emissions inventory started first of all with discussions with City of London Corporation to first understand the kind of activity data that they had for all the emission sources that they had identified. Next, we had to find a way to gap fill. So for any data that was missing, we found sources of data and they made some assumptions for what was missing. And next, we then had to devise a plan on how to display this data. So for some sources, for example, the road sources, we decided that we would display the emissions as road sources or road emission sources in the map, because we knew where the roads were. And we did the same thing for CHPs and boilers, because we had the locations of all the CHPs, so we could display the emissions in the GIS formats. The next thing we did as well was a discovery and research for the study, which I'll discuss in the next few slides. So this discovery and research review was basically undertaken to understand the composition of PM2.5, to check that all the sources have definitely been identified, and also to then compare the outcome of this emissions inventory to other emissions inventories that have been carried out, that have been done in Europe and in the UK, just to see if there were any similarities or differences. The first part of this discovery and research phase was a look at PM2.5 composition. We reviewed several literature and we found one relevant literature, which I'll discuss now. And this was a study by Yin and Harrison in 2008, which looked at PM2.5 monitoring data at 3 urban background sites in Birmingham. And this study found that 26% of the PM2.5 was composed of organics, and 5% of the PM2.5 was composed of elemental carbon. And both of these are typical combustion sources and also typical of natural sources. 6% of the PM2.5 consisted of iron particles, and this is typical of road vehicles. 3% of the PM2.5 consisted of calcium salts, and this is typical of construction activities. And then 4% consisted of sodium chloride, which is typical of natural sea salts. There were also really high contributions from ammonium and sodium nitrate at 21%, and ammonium sulfate at 24%. However, the authors didn't provide any indication to what might be the source of these two components. But there was another research that we reviewed, which indicated that nitrates would most likely have come from the spreading of fertilizer. So next, in the discovery and research, we wanted to understand all the main PM2.5 sources. We wanted to understand the percentage contribution of PM2.5 across all these different emissions inventories that are available. And then we wanted to be confident that City of London had identified all the relevant sources of PM2.5 for this emissions inventory. So the study that was done in Western Europe looked at 419 source apportionment studies across about 51 countries. And the study found that traffic had the highest contribution to PM2.5 at 25%. And this excludes the unspecified sources, which was at 44%. The NAEI revealed that residential combustion had the highest PM2.5 emissions at 43%. And the LAEI also identified traffic as the highest emissions for PM as at 31%. However, in addition to the LAEI identifying traffic, we know that it identified some other sources that were not identified in the other studies. So the LAEI identified commercial cooking and also identified construction. So based on all this information, we were able to establish that we had considered all the relevant sources that would need to be used for this PM2.5 emissions inventory. So the list to the right here shows all the sources that have been included in this PM2.5 emissions inventory for City of London. So under transport, we identified road, rail, river traffic, and flights. Under industrial and domestic combustion, we identified combined heat and power, boilers, generators from filming. Under construction, we identified construction non-road mobile machinery, streetworks streetworks NRMM as well, fugitive construction and fugitive streetworks. And lastly, we identified restaurants. So at the start of the emissions inventory compilation, the first thing we needed to decide was what emission factors we were going to use for all the sources that we'd just identified earlier. For traffic, we established emission factors from the corporate database, which is funded by the European Environment Agency, and this feeds into the emissions factors toolkits, which most of you might be familiar with using. So emission factors were obtained for all the different vehicle types in grams per kilometer. For all the other sources, the emission factors was taken from the European Monitoring Evaluation Program, MEP or EEA Guidebook 2019. So there were emission factors for CHPs, boilers, and generators in grams per gigajoules or grams per kilowatt hour. And there was emission factors for fugitives in grams per meter square per year. When it came to restaurants, we found that there was very limited research in this area. However, we found that there was one study done in the US which looked at PM2.5 emissions from cooking. And this study found that the highest PM2.5 emissions was due to the grilling of burgers. So we've been able to use these emissions factors here, just shown to the right, within this study. I think the only thing to note is that this study was done back in 1998. In addition to the emission factors for the food cooking, we got emission factors for the fuel used to cook the food from the MEP guidebook. Next, in emissions inventory compilation, we looked at the activity data. You would note that we had data from some robust data and some less robust data. So I've tried to highlight the ones that are less robust and the ones that are robust, which is data that we're confident about. I've highlighted a few of the activity data that I'll be talking about more because most of the data are quite similar. So I'm just going to talk about the ones that are a bit unique. So for CHPs and boilers, we were provided with number of CHPs and number of boilers. We're provided with the location, their power rating, the type of fuel used, which is gas, but we had to make assumptions on the operational hours. Most of these assumptions were due to some reviews of some studies that showed how many hours CHPs would operate in London. Based on all that information, we were able to establish the energy usage in gigajoules for CHPs and boilers. And then we applied the emission factors in grams per gigajoules to this energy usage. And then we're able to obtain the PM2.5 emissions in grams. The only thing about this aspect is that we were aware that the 40 CHPs and the 100 boilers did not account for all the CHPs and boilers in the City of London. So these unaccounted CHPs and boilers, we refer to them as residual CHPs and boilers. And for this aspect, we then source for information on the total gas used in the whole of City of London, established what the energy usage would be for that, and then subtracted the energy usage for boilers and CHPs in order to get this residual boilers and CHPs, and then multiplied this by the emission factors in grams per gigajoule. Now, this is the next summary of activity data used. And I'll be speaking about the ones highlighted more because they're a bit unique. So for construction sites, we knew exactly where the NRMMs were located, like the excavators, dumpers, and things like that. And so based on their location, we're able to derive what the construction area would be. Once we established the construction area in meter square, we multiplied that by the emission factors in gram per meter square per year. And we did something similar for fugitive street walks, because we were aware that there were 77 highway repair street walks that have been undertaken in the City of London for that year. But we didn't know how much area they covered. So we made an assumption on the fact that they might cover a road section of around 5 meters and assumed a 10-meter road width. And once we established the area from this, we then multiplied it by the emission factors in gram per meter square per year. When it came to restaurants, we had information about the fact that City of London had over 1,000 restaurants in the area. And they gave us information on the ones that used coal and the ones that used wood. And we assumed that everything else would use gas. So once we had information on the fuel, the next thing was to find information on the amount of food cooked by all these restaurants. Because we didn't have that information, we ended up going to source for national statistics on food consumed per week outside of the home for different types of food. And then we applied it to the number of residents, the workforce, and the visitors. And based on this, we established the amount of food cooked in the City of London. And then we applied the emission factors, which I discussed earlier, that was from Norbeck and Welch study. We applied those emission factors in grams per kilogram of food cooked. And then we established the PM2.5 emissions from cooking of the food. When it came to the emissions from the fuel used to cook the food, we first of all assumed that you would need an equal amount of fuel to cook a particular amount of food. And so we applied the percentages shown on this slide. So we applied 3.6% to the amount of food we'd already established for City of London to derive what amount of charcoal will be used in City of London. And we did the same thing for wood. And then we applied the emission factors from the MF, which were in grams per kilogram of fuel, also that showed in one of the slides earlier. At the end of the whole emissions inventory compilation, we deduced that 23 tons of PM2.5 is produced within City of London. And we note that there was minimal contribution from street walks and their NRMM, from fugitive construction dust, from flight paths, and from rail. And all this made up less than 5%. However, restaurants had the highest contribution at 37%. And this is followed by combustion at 20%, NRMM at 16%, traffic at 13%, and finally river traffic at 10%. I think the main thing to know here is that when you compare what we'd established for this emissions inventory for restaurants, you'd see that it was 37%, but when you compare it to what was established in the LAEI, that was 15%. However, cooking wasn't considered in the LAEI, and this is most likely because restaurants and cooking is not considered a significant source nationally. So here are some of the results of the emissions inventory. So the figure to the left shows the mapped vehicle emissions in tons across City of London. And this includes all the emissions from all different vehicle types. The figure to the right shows the mapped boiler and CHP emissions across City of London in points, because we knew exactly where they were located. Next, we have more images on the emissions that was established. So the map to the left shows the mapped street walks at fugitive emissions, and the map to the right shows the mapped generator emissions. And some more mapped emissions, but these two have been taken from National Atmospheric Emissions Inventory. So the mapped aviation emissions have been taken from National Atmospheric Emissions Inventory, while the mapped river traffic emissions have been obtained from the Port of London Authority. So in addition to all that emissions inventory compilation, we decided to do some additional supporting analysis to help understand the source direction for most of the PM2.5 measured in City of London. So we did an open air analysis of the monitoring data in in City of London using monitoring data as well as wind speed and wind direction data. And we did this for 3 years, for 2017, 2018, and 2019. And as you can see from the Polar Plus for 2017 and 2018, you'd see that the highest PM2.5 concentrations were measured when there was a northeasterly and easterly winds. And these two indicates that there's probably a large source of PM2.5 coming from most likely outside of City of London. And when you look at the color plots for 2019, you'd see that the highest PM2.5 concentrations were at very low wind speeds. And we believe this is most likely due to local sources that have not been dispersed properly. Next, we carried out some more supporting analysis looking at calendar plots to understand the seasonality of the PM2.5 monitored concentrations. For the year 2017, we noticed that there were highest PM2.5 measured in January and February. For 2018, we noticed there was the highest PM2.5 measured in the months of April and May. And for 2019, we noticed that there was the higher PM2.5 measured in the months of February and April. And we believe that these episodes in the winter months of January and February are most likely due to combustion sources, while the high PM2.5 episodes in the spring months of April and May are most likely due to the spreading of fertilizer. Next, we looked at another supporting analysis just to understand how much of PM2.5 is from local sources and how much is from external sources, looking at different background maps. The different background maps revealed that 19% of the PM2.5 concentration across City of London was due to sources outside of City of London, while 4% of the PM2.5 was due to sources within City of London. In addition, the highest PM2.5 was due to secondary PM at 49.2%, and the next highest was residuals, which are non-characterized sources plus salt at 24.4%. Point sources contributed 1.3%, but it wasn't clear if these were sources that were within City of London or if they were outside of City of London. However, even if this is considered to be within City of London, then the total PM2.5 concentration from within City of London could possibly be around 5%. So in this study, we've tried to be as robust as possible, but we believe that there's some level of uncertainty, which we think is around plus or minus 25%. And this uncertainty comes from some of the assumptions that we've had to make. We've had to make assumptions on the hours of operation of the CHPs, the boilers, and the generators. We've had to make assumptions on the amount of food cooked, the construction site boundary, the type of generators used for filming. And also, the emission factors that we've used for this study for cooking are quite old. They're basically established in 1998. So they may not be representative of current cooking extraction systems. So our recommendations for this study are for more detailed activity data to be collected so that there are fewer assumptions made when compiling the emissions inventory, and also for more research to be done on emission factors for restaurants and extraction systems that are used in the UK. So in summary, to understand the emissions for a specific area, a bespoke emissions inventory will be typically required because the large emissions inventories may not always provide details on all sources in an area or indicate hotspots. Also, every local authority is quite unique, and it's not always going to be the usual suspect like traffic, especially with the implementation of low emission zones across the UK. So essentially, a robust emissions inventory would require a thorough investigation to understand the main sources in an area. It will also require collection of very good activity data with fewer assumptions. It would require also the use of up-to-date emission factors. So in summary, this study has shown that overall in City of London, they produce 23 tons per year of PM2.5. The main PM2.5 source from City of London is restaurants at 37%, and only 4% of PM2.5 concentration is from inside City of London. Thank you all for listening. I hope you've enjoyed that. And I'll be happy to answer any questions. And if there's anything I can answer, I've got my email address just below, so you can always forward that to me.
Thank you so much, Angela. That was such an interesting presentation. Really amazing and interesting to see those different contributions to PM2.5 levels in the City of London. To all of our attendees, please do put your questions for Angela in the Q&A box. We're going to kick straight off into those now. So you mentioned in as part of the limitations that a number of assumptions had to be made due to a lack of data in some areas. How confident are you in the study outputs, and do you think the emissions inventory is robust enough to inform mitigation measures?
That's a very good question. I just wanted to say that the reason why we've come up with this, the uncertainty that we said about plus or minus 25% is because of the assumptions. And we're reasonably confident more because we can see that we're not too far off from, say, for example, what the LAER is saying in terms of the amount of emissions from restaurants. So we're somewhere in between, but we understand that there's that uncertainty already, as we said earlier. So even if we ended up using, say, lower emission factors for example, the restaurants, we'll probably be saying we're like half of that. So at the moment, we believe that it's quite as robust as it can be, because when you look at all the data that we got from City of London, they gave us so much data. In my experience, not everybody collects that much data, but we had very robust data in terms of how many CHPs they had, how many generators they had. There was so much information. The policies that they had limited data, I tried to explain and say there was limited data, but based on the fact that most emissions inventory would not necessarily be able to even collect as much data, they have gone as far as possible. So I would say it's reasonably robust and they can rely on it.
Great, thank you. And does your generator figures include backup generators? And if so, are you confident that you've included all the generators in the city?
So that's a good question about the generators. So yes, the generators included backup generators. And what City of London did was they had a list of all the generators that they had on their books. But in addition, what they did was do like a walk around survey. So if you look at one of my slides, I refer to something called residual generators. So we have included backup generators and assumed that they would all operate for about 16 hours. The only thing just to say about the generators is that it's possible that some of them might be running more than 16 hours, but that's where the assumptions come in. So ideally, when you do something like an emissions inventory, it'd be good to get the amount of hours that the generators operate. But most of the permits for most of these generators would specify like 1 hour testing for every, I think, 3 months, something along those lines. So we were a bit confident that we'd use the best available data that we could find.
Great, thank you. And in terms of the pollution from aircraft that you mentioned as one of the sources, do you know what the source of that was and which airport was the principal source in question?
Honestly, I did not gather that data, and that data wasn't established by this study. So we took the data from the NAEI.
Great, thank you.
Yes.
That makes sense. We've got an attendee here that said, thank you for such an interesting and informative presentation. And they've asked, would you be able to put a tag on the level of uncertainty of the inventory, and how long was the study done for?
A tag. So I did say earlier that the level of uncertainty is plus or minus 25%. I didn't write it in the slides though, but that's the level of uncertainty. I'm sorry, what was the other question?
And how long was the study?
So we actually did this study exactly 2 years ago. So it's been a while, so I've had to refresh my memory. So we did it study 2 years ago, and it took us about 2 months. They wanted a quick turnaround, so it took us about 2 months to do this. But I believe City of London were already aware that they were going to be doing something like this. They'd been gathering the data already. And then when they didn't have the data, we would ask them, can you find this data? Can you find that data? And when they couldn't, then we ended up coming up with assumptions or gathering some of the data by ourselves.
Great, that makes sense. Thank you. And for the data that you were given, what quality assurance measures were in place for this?
The main quality assurance was hopefully relying on what City of London had told us. And then our team has lots of experienced people that are used to dealing with emissions like industrial combustion emissions. So we had them looking at the data. So we had information on, say, for example, the Euro standards of some of the, say, for example, generators. So we were able to check that this met what they said on the spreadsheet that we sent.
Great, thank you. And then one of our attendees has said, did any of the findings or results of the study surprise you?
Definitely, yes, especially the restaurants. We weren't expecting that. I think we tried to be as conservative as possible. Maybe not conservative is the right word, but we tried to like screen the data down to see, can we get this any lower based on all the assumptions, knowing how many people are going to be eating there, their lunch breaks there, visitors are going to be coming there. The numbers are crazy. But yes, based on that, even if we try to be as reasonable as possible, we still found that the restaurants were still higher. So that did surprise us.
Yeah, that makes sense. And given the high proportion coming from restaurants in this study, what do you think the implications of those findings are in terms of actually meeting targets for PM2.5 reductions?
Yes, it's definitely something that most local authorities and especially City of London would need to be looking at how to manage restaurants more, because there's not enough guidance and not enough information on how much emissions are coming from restaurants. So one of the things that came out of this study was City of London went ahead to see if they could get funding from DEFRA on monitoring of emissions from from restaurants, basically in City of London, I think, and a few other London boroughs as well. So I'm not sure if they've got funding for that yet, but that's something that has come out of this study.
Great, thanks. And do you think that given the high proportion of commercial cooking in restaurants in terms of PM2.5 contributions in London or the City of London means that it's a source that's been kind of neglected in other emissions inventories that have been done?
Well, not necessarily. I think the only thing I'll say is that City of London is really unique in terms of the amount of people that go there. Some other place in a very rural area would not have the restaurant emissions being so high. But it's just something that people need to be aware of, really, because if you have a lot of restaurants and they're cooking outside, grilling their burgers regularly and not using any extraction systems, then it's definitely going to be a problem. And when you think about the fact that most places are now introducing low emission zones across the area, where people always think, oh, traffic is the main problem here, but it might just slowly, the amount of traffic contribution is slowly reducing, that something else is going to take over. So it's something that people need to be aware of.
Great, thank you. And I think you did mention this in your presentation, but just to reiterate, for restaurants, did the City of London provide data on the fuel type used? And if so, do you know how this was collected?
They seem to have a database of they have a database of all the restaurants. As I said, this slide that's still probably currently sharing. They gave us a database of about over 1,000 restaurants in the City of London. And it seems to be that one of the criteria will be if you're using any fuel apart from gas, you need to specify it. So they were very specific, and they had that information that 41 used coal and 8 used wood, especially ones that especially pizzerias, places that cook pizza, and everybody else would typically use gas. So they were quite confident with the data, and we took their word for it, really.
Great. And how did you calculate the uncertainty level of the inventory, and how does this compare with the LAEI?
The level of uncertainty mostly is from experience, really. There wasn't any, but it's from experience and also from the emission factors that we could have used. So when we compare it to emission factors that we could have used, and then also the assumptions that we were making, we came up with the uncertainty that it will be around plus or minus 25%. And then comparing to the LAEI, I didn't do as much digging around into the LAEI to see what procedures they did, because we're just focusing on doing this emissions inventory. So apart from the fact that I've showed all the contributions from different sources from the LAEI, we didn't dig in to see what uncertainties were there. That was where we ended our review.
Okay, thank you. And then one attendees put, apologies if they've misrepresented this, but did the data suggest that only 4% were from emissions within the City of London? And if so, where is the 96% being created from or originating?
So there's the DEFRA background maps, and this, I'm hoping I'm still sharing my slide.
Yes, yeah.
Yes, so the DEFRA background maps shows all the different contributions from different sources. And the ones within City of London for road, industry, rail, and domestic is the 4% I'd mentioned. And then they were very specific about the ones outside of City of London for all those sources as well, road, industry, rail, and domestic. And that was 19%. And then everything else, as you can see, there's a big contribution from secondary PM, which I mentioned earlier, is formed in the atmosphere from mixing of gases, and then they condense. So the exact sources, it's not really clear, but that's where the whole 100% comes from.
Great, thank you. Well, thank you for answering so many of these questions. I think that's probably all we have time for today, but really appreciate you coming in and presenting for us on this study. To all our attendees, I'm really sorry if I didn't quite make it to your question, but we did get through quite a few. So that is it from us today in terms of the webinar. Thank you so much for logging in. I hope you found that beneficial and informative. And if you're an IQM or IES member, please don't forget to record your attendance using the IES CPD tool, which you can find in the members area. This webinar has been recorded and it will be made available on the IAQM website and on the IES YouTube channel. And if you are watching the recording on YouTube, please do subscribe to our channel, like the video, and hit the bell to gain notification of new content. Our next event is an IQM webinar on the effect of Euro 6 vehicle defeat devices on urban air quality, taking place on the 13th of March. And this is a free event, so please do visit our website to register. And I also wanted to flag that the IQM have announced that the next Dispersion Modelling Using Group conference will be held on the 25th of April 2024 in London. And you can register for this now on our website as well. And another massive thank you to our speaker, Angela, and all of you for watching. Thank you very much.
Thank you.